All right, stats class, this is the formula sheet for chapter 6, so I recommend you print it and write all over it like you would in class. And I'm going to go over it just to make sure, since some people will be absent. I recommend you use this as a weekly summary. So this first part is from lesson 6.1. The mean or expected value of a random variable is just the sum of all the values times their probabilities. And then the standard deviation is square root of the sum of x's minus the means squared times the probabilities. So it's not likely that you'll actually need to use those formulas very much. Actually, I take it back. I would like you to write out at least a little bit of it and like a dot, dot, dot to show that you know the formula before you put it in your calculator. But of course, the calculator can do both of those. And then in 6.2a, we learned how to recenter things, and that's the linear transformation rules. Basically, if you add and multiply, it does the same thing to the mean. So a plus b times the mean of x. Just take your mean and multiply and add those same numbers. Rescaling is when you're multiplying, it stretches the graph, but the adding does not make a difference. So the a does not even show up in these next formulas. Don't think I gave you this one yet, so I'll come back to it. This is the one with the b times standard deviation of x and then the absolute value, just because if b happened to be negative, you would need to make it positive. You can't have a negative spread. But basically, it's just saying that if you do this a plus b thing, the b affects the standard deviation by multiplying it. The a does not affect the standard deviation. And then if you want to do the variance, which is sigma squared, you just square all of this. And squaring the absolute value thing just gets rid of the absolute value anyway, because squared is already positive. And then this is sigma x squared. So that formula I may not have given you, but it is in most of the books, so just to be sure. And then in 6.2b, 6.2a was linear transformation. 6.2b was combining, which is adding and subtracting random variables. This is what we did in the ice cream and cake Desmos, which I hope you enjoyed. Mu x plus mu y, we're just adding the two means together. We can subtract the two means. That's pretty predictable. This is exactly what you would expect it to do, and you could prove it with algebra by writing out the definition of mean and finding out what happens if you add them together. I am not going to do the proof for you. Variances, you can add the variances whether you're adding or subtracting these. So you can do standard deviation squared of x plus standard deviation squared of y. And then the same exact formula down here. Notice this is a plus, and that's not a typo. It's really supposed to be a plus. Standard deviation of y squared. You can add the variances together in both of those situations. And then last but not least, if you want to find the standard deviation without the squared, instead of the variance, you just take this formula and square root it. So sigma x squared plus sigma y squared in a square root looks like the Pythagorean theorem because it is, basically. And then this one does the same exact thing, again with a plus and not a minus. Make that extra bold to make sure you know that I'm not making a mistake. It really is adding the variances and then square rooting. And then I like to put these in words also. So back to the transforming, these first two are the transforming variables. In words, basically, if you do certain things, it changes the center but not the spread. The thing that changes center but not spread is that a, which is being added. If you add or subtract a constant, which is a number, it changes the center but not the spread. If you multiply by b or divide, it would change both the center and the spread. Multiplying or dividing by a constant changes the center and the spread, and that's basically what this formula is saying with the b showing up in all three places. And I want to point out that that's different than what we did when we added or subtracted two things. So this is talking about a number and a random variable and how they relate. This is talking about two separate random variables. So if you do random and more random, you get the mean of the sum equals the sum of the means. That's this formula in words, and I really like it. Mean of the sum equals the sum of the means. The mean of the difference, that's this, equals the difference of the means. So those are very pleasing sentences, I think, for those same things. And then this is the one that's weird. The variance of the sum or difference It doesn't matter if it's a sum or a difference, you still get the sum of the variances, and I'm capitalizing that because it's so important. So that was a very short video just to make sure you have your formula sheet right. Like I said, I recommend that you make this at least part of your weekly summary, and then we'll do the notes in a separate video.